I was substitute teaching for a high school math class. I believe it was Algebra 2, possibly pre-calculus. I'm not 100% sure. But there was a problem. What they had just gotten their test back this day, and the students were asking, how to solve all these problems, why did they get it wrong, etc. And there was an extra credit problem on the last page, and I will draw it here roughly. There was an angle, and this could be any angle, it doesn't matter. And the question said, I'd asked the students to bisect the angle. So bisection means cut this thing exactly in half. Well, exactly as you can with, a piece of paper and a pencil. Obviously, in the real world, you can't do something 100% exactly in half, but in your imagination you can. In the world of Platonic mathematics, you can do that. But in the real world, there's messiness with the thickness of the marker and imperfections of the tools you're using. So, imagine that this is the last piece of pizza and you have to share it with somebody. So you make the first cut and they get to choose which half they want. So you want it to be almost exactly perfect. There, piece of pizza. So how would you go about doing that? The reason I bring this up is because I think that students get a little bit too much information and they get stuck in thinking that there's only one way to do something, and that's almost never the case in mathematics. There's a lot of leeway for creativity, lateral thinking, all kinds of different solutions. And if you're taught that you have to do something, for example, how to multiply or how to do long division, you're taught an algorithm to do that, or a procedure, and then you follow that procedure exactly and then you get the answer, right? It's sort of, you imagine that it's like this mechanical thing that you spit something out. But it's a good idea to not get caught in that trap, because especially when you get on, if you go on to higher mathematics or science, engineering, anything like that, you're going to be faced with problems that there aren't procedures for, and you might have to even invent the procedure for that. So you need to be able to leverage your full imagination and creativity, and if you get stuck, you're not going to be able to solve the problem. None of these students got this problem right, and they're all wondering how to do it. So I'll just show you how. They've all probably taken high school geometry, so they're going to learn how to do it with a straight edge and a compass. This is a compass, ruler is a straight edge, basically, minus the ways of measuring things. You don't get to do that. So normally what you would do is something like this. Just don't worry about them. You would use your compass, you would mark out an arc, and then you would make something like this. And where those two meet, from here to there, it's exactly halfway. So that would be how you do it using a straight edge and compass. And they were stuck because they thought, oh, this is the way we have to do it, and we don't know any other way. But I think young kids can figure out how to do this. Maybe not. But and I don't know if this is the one solution. I don't even know if this is what the teacher had in mind, but this is how I showed them how to do it. Is I just took the piece of paper in half, I folded it in half, and just looked through until I could line up the two edges. It's probably not easy for you to see, but I'll show you the end result. It looks like that. So just by folding the piece of paper, you can actually solve the problem. Maybe it's not obvious, but it's definitely not obvious if you think that you have to follow a procedure to solve the problem. There's not always a procedure. Thanks.